In question 1927, we're asked to find the collector current and the collector to emitter voltage in this circuit. So notice we have a PNP transistor, and it is powered from a minus 12 volt source. So first of all, we're going to assume that the transistor is working properly. And so we're going to assume that the voltage from base to emitter is 0.7 volts. Now in this case, it will be minus 0.7 volts. And the reason is because it is a PNP transistor. So it's minus 0.7 volts from the base to the emitter. Therefore, we can say that the voltage from across the base resistor, RB, is equal to minus 12 volts minus voltage base to emitter. And that gives us minus 11.3 volts. So that's the voltage drop across this resistor. Because we know that voltage drop, we automatically know the current in the base. That's simply equal to the minus 11.3 volts divided by the 360 k ohm resistor. Notice that base resistors are typically quite high. And that gives us a minus 31.389 microamps. And base currents are typically very small, in the neighborhood of microamps. What the minus means is that the current is flowing this way, in the opposite direction that we would have if we had a positive supply. Now, we were also told that the beta for this transistor equaled 150. Knowing the beta and the base current, we can find the collector current because IC is equal to beta times IB, which means that it's equal to 150 times the minus 31.389 microamps, and that equals minus 4.7083 milliamps. And again, the minus sign indicates that the current is flowing this way. So knowing the current in the collector resistor and knowing its resistance, we can find the voltage drop across the collector resistor RC. That's simply equal to 1,000 ohms times the current flowing in it, which is minus 4.7083 milliamps, is equal to minus 4.7083 volts. Whenever you have kiloohms times milliamps, the terms basically cancel out and you end up with this number of volts. Now that we know the voltage across this resistor, we can now determine the voltage across the transistor. So we can say, therefore, voltage from collector to emitter is equal to the minus 12 volts we have up here, then minus 4.7083 volts is equal to minus 7.2917 volts. So there's the voltage from collector to emitter, and here is the collector current.